Hello everyone, welcome back to my channel. My name is Dr. Yogita Bisht, and in today's video we are going to study about the basics of the mole concepts. In this video we will talk about what is mole and from where this term comes, and what is AMU, what is atomic mass, what is relative mass, right? And this mole concept is very important because this will form the basis for the other complex terms. For example, normality, molarity, molality. In all these terms you are supposed to calculate the number of moles, and there are different formulas for doing that. And most of the time what students do, they tend to mug up these formulas. But if your basics are clear, you need not to remember those formulas. It will come to you naturally. Okay, so that's why I would request you to pay attention to these small terms or very easy terms. Okay, all right, so let's just start with the first thing, that is, what is mole? It is represented with small n. So what actually mole is? Mole is nothing but it is a measurement unit. What is a measurement unit? With the help of which we measure anything. So for example, if we have to weigh find out the length of something, its unit is meter, right? If you have to weigh something, its unit is kg. Similarly, it is a measurement unit for amount of substance. Amount of substance. And remember, it is the SI unit, because in chemistry or in physics also, in all the numerical, we do everything in terms of SI unit. So it is the SI unit of amount of substance. But what it is actually? Okay, so you can compare it with the for example, same as dozen or maybe pair. So when I say I have 1 dozen eggs, it means I have 12 eggs, right? If I say I have 1 dozen banana, that means I have 12 bananas, right? Similarly, if I say I have 1 pair of shirt, what does it mean? It means I have 2 shirts, right? So these numbers are fixed. If I say 1 dozen, it means 12. I have, if I say 1 pair, it means 2. Similarly, when I say 1 mole of a substance, it means 6.022 into 10 raised to power 23 substance. Okay, this number is very important. So if I say, for example, I have 1 mole of carbon atom, what does that mean? It means I have 6.022 into 10 raised to power 23 atoms of carbon. If I say I have 1 mole of water, what does it mean? It means I have 6.022 into 10 raised to power 23 molecules of water. Okay, if I say I have 1 mole of, let's say, oxygen, it means 6.022 into 10 raised to power 23 atoms of oxygen. If I have 1 mole of O2, what does it mean? Why? Because oxygen exists in diatomic form, so O2. So I have 6.022 into 10 raised to power 23 molecules of oxygen. Okay, so this number remain fixed, and this number is called as Na, which is Avogadro number. It is named after scientist Avogadro, and he has also given very famous law, Avogadro law. So it is named after him. So you can see that here this substance can be anything. Okay, so we call it as elementary unit. So this unit can be any atom, it can be any molecule, or maybe ions or particles, in fact group of particles also. Okay, so I hope this thing is clear. So the moment you hear, now onward, whenever you hear this term 1 mole, 6.022 into 10 to the power 23 term should come in your mind. All right. Okay, so I'll come back to this part once again. First, we need to go back to a little bit of history to understand what is relative mass, what is atomic mass, and so on. Okay, so now we have, nowadays scientists have such a sophisticated instruments that they can actually measure the mass of an atom or a molecule easily, but earlier there was no such techniques. Okay, so what they did is, earlier what they, in initial days what they did is, they thought, okay, hydrogen is the lightest element, so let's just consider mass of one hydrogen atom, they consider as 1 without unit. Okay, and then they assign mass to other elements on with respect to the hydrogen. So that was called as relative mass. So every other element was given the mass, like carbon or other elements, they were provided, okay, how much it weigh with respect to hydrogen atom. Okay, but later on they moved to carbon 12. They thought, okay, carbon is present in more abundance and it is more stable, it doesn't react that much easily, right? And there are other factors also. On the basis of that, they decided, okay, hydrogen doesn't fit that much, so we should consider carbon 12 as the standard atom. Okay, and they considered the mass of one atom of carbon 12 as 12 AMU, or simply AMU without dot. This is nothing but atomic mass unit. Okay, and they gave the mass to other element like hydrogen or oxygen, nitrogen, all other element with respect to carbon 12. Now you must be wondering why I have written carbon 12. So carbon 12 is one of the isotope of carbon. There are different isotopes of carbon, carbon 12, carbon 13, carbon 14. Okay, so here the atomic number is same but their mass number is different. So the standard element that they consider at that time was carbon 12. Okay, so we will come back to this isotopes isobar later on, or maybe you already have some idea. So it's not that complicated thing, but just remember one thing, that at that time they consider the mass of the one atom of carbon 12 as 12 AMU. Okay, and then they converted, or they weigh every other element relative to this in terms of AMU. Okay, so if you want to convert anything, any mass in AMU, you need to remember this relation. So we can easily say that 1 AMU is nothing but mass of one atom of carbon 12 divided by 12 from this relation. Okay, so somehow if I know the mass of one atom of the carbon and if I divide by 12, I can easily find the value of the 1 AMU. Of course, this is in gram. Okay, and another thing that I would like to point out here is, nowadays we don't use the term AMU, rather than we also call it as U, that is unified mass. Okay, so if you hear this term, don't get confused, it is same as that of the AMU. Okay, all right. So another thing that you need to remember is, numerically 1 AMU is same as that of 1 gram per mole. And what is this? This is the unit of atomic mass. Okay, so now we are moving to the atomic mass. So I hope this thing, till this thing, everything is clear. It was the mass of atom in earlier days, and the unit was AMU or maybe U. Okay, but nowadays we don't talk about the relative mass. This was a relative mass, right? But nowadays we talk about the atomic mass or molecular mass. Okay, so what is atomic mass? It is the mass of 1 mole of that atoms or molecule. Okay, so as per today's understanding, if I say that atomic mass of carbon 12 is 12 gram per mole, what does it means? It is not the mass of one atom, it is the mass of 1 mole of the carbon. Okay, and we already know that is it is the mass of 1 mole of carbon 12, which is 12 gram. Okay, so we already know mass of 1 mole of a substance. That means here 1 mole is nothing but 6.023 10 to the power 23 atoms of carbon 12. This is the mass of this much. It is 12 gram. Okay, now what we are trying to do here is we are trying to find out the value of AMU. 1 AMU is mass of 1 atom of carbon, so I have to divide by 12, but I don't know the mass of 1 atom of the carbon. Okay, so we can find out the mass of 1 atom of carbon with the help of this. So mass of 1 atom of carbon 12 will be 12 divided by 6.023 10 to the power 23 gram, right? So what we can do is we can just put it in the formula. The formula here is 1 AMU is mass of 1 atom of carbon divided by 12. So mass in AMU is mass of 1 atom of carbon divided by 12. So what we have to do is we have to just put this value. This is the mass of 1 atom of carbon. So if I put it here, 12 divided by 6.023 10 to the power 23 and this 12. So 12 cancel out. So 1 AMU is nothing but 1 by 6.023 10 to the power 23, or you can say it as 1 over Na. It is the Avogadro number, I told you already. Okay, and if you want you can calculate this also. So this will be 1.6605 into 10 to the power minus 24 gram. Okay, so if you are provided with the mass of any element or any atom in terms of AMU, you can easily convert into gram just by multiplying it by 1.6605 into 10 to the power 24. So this is another important formula. All right. So you must be wondering like how do we get to know that this is the mass of the 1 mole of a substance? So with the help of mass spectroscopy or today's instrument, it is easier to do this. Okay, and another thing that you must be wondering is like why not to work in terms of atoms, right? Why we are talking about moles? The reason being is atoms, molecule, these are the microscopic particle, very very small. Okay, so it's not possible to accurately measure them, right? So that is why the scientists come up with the moles. They consider, okay, Since under fixed temperature pressure they contains the same number of moles, same number of particles. So let's just measure everything in terms of moles. Since it is a bigger unit, will be able to, the instrument will be able to measure it more accurately. Okay, so that is why nowadays everything is measured in terms of moles, and with the help of moles we can easily convert into atoms or molecule. We know the relation, right? Okay, so it's very easy. Let's say if we know the mass of hydrogen at the atomic mass of hydrogen, then we can easily convert into AMU, or we can easily convert into terms of grams. So it's very easy. So I'll start with one of the numerical. Okay, so the question is, the atomic mass of silver is 107, excuse me, okay, yeah, so it's 107.87 gram per mole. Find out mass of silver atoms in gram and in AMU. Okay, so atomic mass is already been given. We have to find out its mass in gram and in terms of AMU. So how to start with this? So the first information which is being provided to us is atomic mass of silver is this. What does it mean? It means atomic mass of silver element is 107.87 gram per mole. It means mass of 1 mole of silver is this much, right? So mass of 1 mole means it is 6.022 into 10 to the power 23 atoms of silver is 107.87 gram. So we are supposed to find the mass of silver atom, one single atom of silver. So we can easily do that with unitary method. So mass of one atom of silver will be 107.87 divided by 6.022 into 10 to the power 23 gram, right? So we can easily calculate that. So this is 1.79 into 10 to the power minus 22 gram. So please remember, sometimes you're supposed to express in terms of kg. So be careful what has been asked in question, whether it is in gram or in the kg. So this is the mass of one atom of silver in gram. Okay. Next question is, what will be the mass in AMU? Okay. So we do know that what is AMU, we have just find out. 1 AMU is 1.6605 into 10 to the power minus 24 grams. Okay, so there are two ways of doing it. One is a straightforward thing. I have already explained to you that numerically 1 AMU is same as that of the 1 gram per mole. So we know directly 1 AMU is same as 1 gram per mole, and the answer in 1 gram per mole is already been given. Therefore mass of one atom of silver in AMU would remain same, that is 107.87 AMU, or just U, unified mass. Okay, but if you don't remember this formula, there is other way of doing it as well. Why? Because we already know that 1 AMU is nothing but mass of one atom of carbon 12 divided by 12, right? So you can just put like this as well. So like whatever way you want, you feel comfortable. If you don't want to remember anything, you can do that, because for this you just need to remember one thing, that mass of one atom of carbon 12 was given as 12 AMU. So if you don't remember the other formulas like 1 AMU same as 1 gram per mole, you can just remember this, and with the help of this you can easily calculate this, right? So mass of one atom of carbon is 12 divided by 6.023 10 to the power 23 divided by 12, 12 cancel out. So 1 AMU is 1 over 6.023 10 to the power 23 grams. So we have already calculated this in terms of gram, right? Or rather we can put this as well. So we already know the mass of one atom of silver in gram. We just need to put it over here and we can easily find out in terms of AMU, and the answer would remain the same, right? If you want, I can show it to you as well, right? It's same like here. If you put it over here, 6.022 will get cancel out. Sorry, some point I have written 2 another 6.033, because it's a big number. You just need to round it off. Certain books write it at 6.022, other books write it at 6.023. So normally it has been provided in the question itself. If it is nothing, if nothing is given, then just assume that it is 6.022 10 to the power 23. Okay, so with the help of this formula also you can easily calculate the mass in 1 gram in AMU, or maybe in gram per mole. Okay, so I hope these things are clear. So as a homework, your question is find the mass of one atom of maybe copper in AMU and in grams. Okay, atomic mass you need to search in the book, and the answer you can just comment down below. Okay, and if you find any difficulty in understanding these type of questions, or the question that I have explained over here, if you have any confusion, you can just comment there, and I'll try to answer all these questions. Okay, all right, so in the next video we are going to use these things to find out other formulas to find out the number of moles, because there are chances that sometime you will be provided with the mass or maybe number of molecules, and then you're supposed to calculate the number of moles, and then using those number of moles you're supposed to calculate the molarity or molality. Okay, so if these things are clear, then it's very easy for you to find out the number of moles easily. Okay, so that's it for today's video. Thank you so much for watching. I'll see you in the next video. Thank you.